common factor. We're going to move on to factoring by grouping now. So it's exactly like how it sounds. We're just going to group stuff together, factor it as if it was one single expression like we did in the other videos, and then we'll see what happens from there. So here's an example of factoring by grouping. You see, if you wanted to go about the GCF way, 10, 5, 4, and 2, there's no number that goes into all of them. So you can't do the GCF thing here. And as far as the variables, some have variables, some don't. You'll just know which form it's in after you try a couple examples. You'll know if it's GCF, trinomials, or grouping. You just take some practice. But this is just screaming at me that it's by grouping. So I'm going to group these guys together, and then I'm going to group these guys together, factor it like it was just a normal problem, and then you'll see what I'm talking about. So for these guys, if you're looking at the numbers 10 and 5, 5 goes into 10, so that's already the GCF. Yeah, we're factoring these like the GCF problems that we did earlier. So there, as far as the numbers, we already took care of that. We said that as far as the variables, you factor out the one with the lowest exponent, which is 1 here. We're going to pull out an x to the 1. So 5 goes back into 10 2 times. There's an x squared here, so I need another x to get back there. And this 5x I completely factored out. So I would need a 1 to hold the spot for me when I pop it back in. Okay, moving on over here, I'm going to put a plus sign. As far as the numbers, 2 goes into 4, so that's the GCF, and there's no variables here to factor out, because only this guy has a variable. So I would need a 2 to get back to that 4 and the x, and since I took the 2 out, I would need a 1 to hold its place. Whenever you factor something out that's already sitting there, like the 2 here, or the 5x I did there, you put a 1 there to get back what you had. So now this is going to happen, I want to say 99% of the time. I don't want to say 100 because in math, something weird could happen. But it's always going to work out in a way where when you factor it separately, you're going to get like the same thing inside these parentheses here. You see the 2x plus 1 and the 2x plus 1? That's always going to happen. So you're going to know that you're doing it correctly or not. So the deal here now is to factor out what they have in common. See, this guy is being multiplied to this term here, and this 2 is being multiplied to that term. And it's the same term, the 2x plus 1. So we could factor that out of both of them. So factoring out a 2x plus 1, so since this came out, right, the 5x is left. And since I took this 2x plus 1 out, I factored it out, the 2 is left. And that's as far as you could go. So we'll do a couple more examples. It's the same thing as GCF. It's just something new will appear here, and then you'll just factor that out again. Okay, so another example of factoring by grouping. You might have to rearrange the term sometimes to factor by grouping, but the way I've set it up for you guys, it's already set up in a way to just start factoring by grouping. So we're going to group these and these guys together, right? Like we did in the other video. So looking at this guy here, I'm going to focus on the numbers. So it's 2 and 6. Since 2 already goes into 6, that's the GCF as far as the numbers, right? And then with the variables, I said to factor out the one with the lowest exponent. So that would be x to the 1, or just, x. So I would just need an x here to get back that 2, right? The x squared. And then 2 goes into 6 3 times. And I already pulled that x term out, right? So 2x squared plus 6x, there it is right there. Now, moving on over here, right? Here's a subtraction sign. Like in the other video, I just wrote the plus there, remember? I said plus, and then I factored out whatever was going on. Remember how I said you're going to factor stuff out of both, and then this inside parenthesis has to look the same on both? So you could just write that negative sign, but what we're really doing is factoring out a negative, because if I were to factor out a positive, I wouldn't get exactly what's in that parenthesis. But if I factor out a negative, as you're about to see right now, So if I factor out a negative out of here, it's like there's a negative 1 right here, right? So if I take that out, I would just have an x left. And then if I factor this negative out of the 3, it'll be a positive 3. See, now these are exactly the same. If I were to not factor out a negative, if I were to factor out a positive, let's say, I would get the same thing again, right? I would get negative x minus 3. That's what would happen if I factor out a positive, which is not the same as this. So, you don't really have to think about it too much, but you want what's inside these parentheses to match up exactly. So you might have to think a little bit here about whether you're going to factor out a negative or a positive. But, you could just write the negative here, but, we're factoring out a negative. Okay. So now that these match up exactly the same, right, because this term has x plus 3 multiplied to it, and this negative 1 has x plus 3 being multiplied to it. So I could pull the x plus 3 out because they both share that, right? It's a term I can pull out of both. So if I pull out the x plus 3, this 2x would remain, and this negative 1 would remain. So this is what the answer would look like as far as factoring by grouping. The hardest it's going to get is, it might not always be on the right side, it might be on the left side, but it's just how am I going to factor it so the inside of the parentheses match up exactly. Okay, so another example of grouping by factoring. So why don't you guys go ahead and attempt this, and then I'll go over it with you. Okay, so remember I said focus in on the numbers first. So since there's no numbers here, we're assuming that there's a 1 here, right? And we're not going to factor out a 1. 1s don't really do anything, right? Like I could put a 1 out here, like I factor out a 1, but it won't make any difference to the problem. If it was a negative 1, it would, but a positive 1 never makes a difference. So moving on to the variables now. The lowest variable here is x to the 1, so I'm going to factor out x to the 1. Again, see these 1s here, I don't have to write them. It's just for our understanding, right? So I'm just going to erase them now. So x, we need another x to get back to x squared, right? And then we factored out this x here, right? Remember when we factor out the thing that's just sitting there, we put a 1 to replace it? And then here's that negative thing again, right? We're factoring out a negative out of here, right? We're not just writing the subtraction sign here. So we're factoring out a negative out of the negative x. And I forgot to, we're grouping this and these terms individually, right? So factoring out a negative, we would get x plus 1. See, the goal, I don't care what anyone says, the goal is to get these parentheses to match up exactly so you can factor them out again. That's really the main point of factoring by grouping. So I got that to happen, so I'm going to pull the x plus 1s out because this x and this negative 1, they're being multiplied to it. They share that, so I'm going to pull that out. So I get an x plus 1, and then what remains is the x and the minus 1, since these were taken away. They were detached from it. So, alright, so another factoring by grouping. I'm assuming you've tried this, so I'm just going to dive right in. Alright, so I'm going to group these and these together. Now, as far as the numbers, there's a 3 and a 1 here. You can't factor anything out of the numbers, right? Because the greatest number that would go into 3 and 1 is a positive 1, and like I mentioned earlier, that won't affect anything. So then I start looking at the variables, because I have 2 variables, I have a and b. So I'll look at a and b separately. There's an a to the first power here and an a to the second power here. We said we're going to factor out variables with the lowest exponent, which is a to the first, right? Just from this guy right here. So we're going to factor out an a to the first power. And as far as a b, they don't both share a b, right? There's not a b term here that I can factor out, so that's it. So I'll get 3a. There's the 1a and the other 1a to give me back the a squared. And then I pulled an a out of here, so it's no longer going to be there. And then there's the b squared. Moving on over here. As far as the numbers, there's a negative 3 and a negative 1 there. As opposed to this one, there was a positive 3 and a positive 1, so the positive 1 didn't make any difference, but this negative 1 will. I'm going to factor out a negative 1 as far as the numbers, right? The constants. And then as far as the a goes, there's not an a term here, so I'm not going to factor out an a. But as far as the b's, the lowest exponent is b to the first power. So I'm going to factor out a negative b. Doing that, I get 3a. What's left over when I pull out the b? There's 3 b's and I pulled out 1, so there's going to be 2 left. See, I made a mistake here, right? Because I pulled out a negative, and if I want it to be a negative again, I have to put a positive here, right? Because negative times a positive is a negative. So you got to watch out. Now, this term is the same on both, right? That's what we always wanted to accomplish, right? So these are exactly the same. A is being multiplied to that, b is being multiplied to that. I'm going to pull that out and get a 3a plus b squared. And then what's left over is just the a minus b.